Okay, let's wrap this one up. We've been discussing the presentation I gave this past summer in Asheville, North Carolina for the Cosmic Summit 23, where we talked about the scientific method and the importance of asking good questions and following through with them. We also talked about the importance of variables in an experiment, and that was an important topic. We spent some time talking about what Carolina bays are, as well as some of the other names for them. We looked at some examples like these, which look like this when viewed with the colorized LiDAR, the USGS LiDAR provided by CNTOS.org and Michael Davies. We then took some time to look at some of the past hypotheses for the formation of the Carolina bays, most of which have not panned out. We looked at a few more examples, like these. Holy cow. We then looked at the current academically accepted hypothesis, which is basically the Carolina bays were created by persistent winds over ponded water, causing the water to swirl and rearrange the sand over a great amount of time, over 100,000 years or so. We then looked at a few more examples, including these at Cape Fear, which were some of the very first ones viewed from the sky. And again, with the USGS LiDAR provided by CNTOS.org, we see that the Carolina bays are much more widespread and much more defined across the entire area, not just those in the Cape Fear River Valley. And then we talked about some of the issues that I have with the current academically accepted hypothesis. That include things like ignoring some really important environmental variables in the experiment, as well as that original 1977 experiment not really supporting the hypothesis. Which again, that doesn't support the scientific method. After that, we looked at some of the Nebraska and rainwater basins for comparison, and when viewed under the LiDAR, we can see that these formations are near identical to the Carolina bays, despite being halfway across the continent, which totally goes against a persistent wind and swirling water hypothesis. And so if we look at the size and the shape and the orientation of all of the Carolina bays and all of the Nebraska rainwater basins and the other similar shapes around the North American continent, I'm comfortable saying that, wind and water cannot do this over and over and over again. It's completely impossible. However, we see them, and there's 70,000 plus of them that have been marked and identified at CNTOS.org and under the Ovoid Basin Survey, which used to be the Carolina Bay Survey. And we can go on and on. If we look at the bedrock geology of Michigan, if we look at the gravitational anomalies of that area around Saginaw Bay, there's lots of reasons why there may be another hypothesis. And so that has led us to another, more probable hypothesis for the formation of the Carolina bays. And that would be that there must have been an impact into an ice sheet over North America at some time in the past, and that the Carolina bays and the Nebraska rainwater basins are a result of that impact. They are secondary impacts from the ejecta of the primary impact into that ice sheet. And so that has led us to the very few researchers that are actually digging into this problem and trying to solve it. One of them being a Mr. Antonio Zamora. His hypothesis basically states that there was an impact into the Laurentide ice sheet at the end of our most recent ice age, right at the Younger Dryas boundary. And it was the secondary icy boulder ejecta that was launched from the initial impact site that came crashing back down, forming the Carolina bays. His hypothesis includes viscous relaxation. It includes conic sections, forming the ellipses. It also includes things like the megafaunal extinction and the loss of the Clovis culture. These are all things that he uses as evidence for his hypothesis. We also looked at the evidence presented by researchers Michael Davies and Thomas Harris. Their hypothesis is considerably different from Antonio Zamora's. They think that this impact happened 786,000 years ago at the mid-Pleistocene transition. Michael Davies believes that the icy boulders would not survive a trip like that, and that instead it was a cavitated ejecta regolith blanket that created the Carolina Bays. That it was a mixture or matrix of sand and water from melted ice that kind of washed over the continent, and it was the cavitated bubbles from that impact, or from those secondary impacts, that created the Carolina Bays. Some of the lines of evidence that kind of support their hypothesis are things like the sudden shift in obliquity, the AA tektites, the foraminifera extinction event that took place at the mid-Pleistocene transition. We also have a magnetic pole shift at that time, and so there's a lot of things that line up with their hypothesis. Then I introduced how the Paleolentic shorelines of our past might be able to help us get a better understanding of the time frame for the formation of the Carolina Bays. I use things like the ice core data from Greenland and Antarctica to match those up with the marine oxygen isotope stages to where we actually see or find the Paleolentic shorelines of our past. And that basically shows us that we have kind of a stair step in levels the last few times that sea levels were higher than they are today, which is really only 2 times in the past million years. That happened once 125,000 years ago, and before that would have been around 400,000 years ago. And we do see those shorelines around places like Myrtle Beach, where we see our current shoreline. We see the shoreline that was created 125,000 years ago, which I have marked in red up here. And we also see the shoreline that was created 400,000 years ago, that's marked in black up there. And it's very distinctive. We also see places where Carolina Bays are very well defined, and we see places where we don't see any Carolina Bays. And the places where we don't see any Carolina Bays are under 30 feet in elevation. It's under that shoreline that was created 125,000 years ago. Now, because we don't find Carolina Bays under that shoreline, that would suggest to me that the bays have to be older than when that shoreline was created, because it was the ocean that rose to remove those Carolina Bays. If the Carolina Bays were formed at the Younger Dryas, we would see them all over this image. They would be from all across the coastal plain all the way to the current shoreline, and they would have extended out into the now ocean. But again, it's that ocean. It's only the ocean there that could erase those Carolina Bays. And I also feel like we see some evidence that the Carolina Bays could have undergone quite a bit of erosion during that last time that the sea levels were higher than that, which was around 400,000 years ago. Because we are lacking Carolina Bays between 30 feet and 42 feet on the seaward side. We do find them on the leeward side, but that would have been like an estuary ecosystem during that time, which may have protected those Carolina Bays. And so where does that leave us? George uses the term the kooky caboose when he's referring to the Carolina Bays and the Younger Dryas. He's always said that the Carolina Bays are kind of that kooky caboose following along behind the Younger Dryas impact hypothesis. But do these Paleolentic shorelines suggest that they're not part of the story at all, that they are much older and may align more with Michael Davies's ideas, at least in timing? It very well could be that, Antonio Zamora has a really good point with how the Carolina Bays could have formed, and Michael Davies and Tim Harris may have a really good point for when they may have formed. It very well could be the solution to this problem is by combining these two hypotheses. And I'm sure there's things that we haven't even thought of yet. And that's really important. Again, that's where we keep coming up with these better and better questions. But how are we going to answer these questions if the Carolina Bays aren't even mentioned in the literature at all? They're not even mentioned at all, completely ignored. You're not going to find them in a single glossary of any geology book, on any college campus, in any Earth systems book in a high school. They're not even mentioned. And they're so important. If anything, I hope that this presentation opened up some eyes to at least include them in the conversation. Because these formations are not only super interesting, but they are also super dominant. They completely cover the East Coast, and they form that arc all around the North America. We absolutely need to be talking about these things. They need to be researched more, and I hope that's what this kind of stuff leads to. I hope it leads to better education and better research. And guys, I'm gonna leave you with that, and you know, I'll be updating things as we move forward. So thanks for following along, and we'll catch you next time. Bye.